Hello, and welcome to Architect of Sleep. Tonight, we are leaving the noisy world behind to travel back in time to witness the birth of our silent companion, the moon. It is a place of deep silence before memory, where a young Earth spun alone in the dark. But that was about to change in a moment of cosmic creation. For now, just breathe. Let your eyes grow heavy and allow your mind to soften. Our journey begins now. Our journey begins in a place before time, a vast dark cloud floating in the emptiness of space. This was our beginning, the great solar nebula, a place of profound stillness and potential. It was a silent nursery for stars and planets, patiently waiting for a signal to awaken. This cloud was not empty, but full of the ingredients for worlds yet to be born. A ghost of a star that had lived and died long ago. We are floating in this cold darkness, at the very start of the story. A quiet witness to the dawn of our solar system. The cloud itself was made mostly of simple things, hydrogen and helium gas, the most common elements in the entire universe. These gases were left over from the Big Bang itself, ancient and unchanging, but sprinkled throughout this gas, like fine powder, was something special. It was cosmic dust, tiny grains of rock and ice, the heavier elements forged in the heart of that long-dead star. These were the true seeds of planets, the building blocks of you and me. And the earth beneath us, a fine, precious dust drifting in the void. The temperature in this vast cloud was almost absolute zero, a cold that is hard to imagine. It was a place where molecules moved slowly, where energy was scarce. The darkness was complete, broken only by the light of very distant, ancient stars. There was no warmth, no center, just a uniform and immense coldness stretching for light years in every direction. This deep cold was important. It allowed the dust and gas to remain calm and to stick together when the time came, a gentle cold that preserved the potential for life. This great cloud was not eternal. It had a parent, billions of years before our sun was born. Another, much larger star existed in this part of the galaxy. It lived its life, fusing elements in its core, and then it died in a spectacular explosion, a supernova. This explosion scattered its atoms across space, seeding the darkness with heavy elements like carbon, oxygen, and iron. Our solar nebula was a cloud of these recycled atoms, a cosmic inheritance from a star we will never know, a beautiful memory written in stardust. The dust itself was so very small, smaller than a grain of sand, more like particles of smoke. These tiny grains were made of silicates, the material of rock, and also frozen water, methane, and ammonia. In the cold darkness, these particles were like tiny frosty seeds, carrying the essential ingredients for both rocky planets and watery oceans. They drifted for millions of years, in a slow, patient dance, waiting for a force to bring them together. The quiet architects of future worlds, the sheer size of this nebula is difficult to grasp. It was thousands of times larger than our solar system is today. It was a sprawling, shapeless entity, slowly rotating in the vastness of the Milky Way galaxy. Our sun and all its planets would form from just a small, dense pocket within this immense structure. It was a cosmic womb, vast and dark, holding the promise of a single special star system within its immense and ghostly arms, a tiny corner of a vast dark room. For millions of years, the cloud just drifted, held in a delicate balance between its own weak gravity. and the slight pressure of its gas. But this balance was about to be broken. From across the galaxy, a shockwave from another distant supernova was traveling through space. It was a wave of pure pressure, an invisible ripple moving through the void. This shockwave, the dying breath of another star, was the trigger that would awaken our own solar system from its long sleep. A gentle push to begin the great collapse. As the shockwave passed through the nebula, it squeezed the gas and dust, creating regions of higher density. In these denser pockets, gravity suddenly had an advantage. It began to pull more and more material inward. A slow but unstoppable gathering. The cloud, once diffuse and stable, began to collapse under its own weight. It was the beginning of a great fall, a journey toward a central point, the birth of a new center of gravity in the universe. As the cloud collapsed, it began to spin. This spin was not new. The original cloud had a very slow, barely noticeable rotation. But as it got smaller, like an ice skater pulling in their arms, it began to spin faster and faster. This is a law of physics called the conservation of angular momentum. All the motion of the vast cloud was now being concentrated into a much smaller space, creating a spinning vortex of gas and dust, a cosmic whirlpool in the dark. This spin became the defining motion of our young solar system. It set the direction for everything to come. The planets would all orbit the Sun in the same direction, and most would spin on their own axes in that same direction. This shared motion is a deep memory, a fossil of the nebula's original, gentle rotation. It is a family resemblance, written in the language of movement, a dance that all the planets still perform together, billions of years later. At the very heart of this spinning, collapsing cloud, something new was forming. The pressure and density became immense, far greater than anywhere else. The gas in this central region began to heat up, glowing with a dull red light. This was a protostar, a star in the making. It was not yet a true star, as nuclear fusion had not yet begun. It was simply a ball of gas, getting hotter and hotter, crushed by the weight of the material falling in on it. A cosmic ember glowing in the center of the swirling dust. The protostar continued to gather mass, its gravity pulling in more and more gas from the surrounding cloud. As its mass grew, the pressure at its core reached a tipping point. The temperature soared to millions of degrees, a heat so intense that it could force atoms to merge. The hydrogen atoms, once floating freely, were now crushed together with such violence that they fused, becoming helium. This process, nuclear fusion, released a tremendous burst of energy and light. A new star was born. The young sun ignited, and a brilliant new light flooded the solar system for the first time. This was a moment of profound change. The darkness was banished, and a new source of heat and energy was established. The sun's first rays pushed back against the remaining gas and dust, creating a bubble of warmth and light in the cold expanse. It was a new dawn, a declaration that a star now ruled this region of space, a lighthouse in the cosmic ocean. The birth of the sun created a powerful new force, the solar wind. This was a constant stream of charged particles, flowing outward from the star in all directions. This wind acted like a powerful broom, sweeping the inner solar system clean of the lightest gases. Like hydrogen and helium, it pushed them far out, into the colder regions of the disk. This process helped to shape the kinds of planets that could form in different locations, a stellar breath that sculpted the worlds. The spinning motion of the collapsing cloud prevented all the material from falling into the new sun. Instead, the gas and dust settled into a vast, flat rotating disk around the star's equator. It was like a potter shaping clay on a spinning wheel, gravity and motion working together to create a flat, orderly structure. This was the protoplanetary disk, the birthplace of all the planets, a cosmic plate from which the worlds would be served. This spinning disk was not the same everywhere. It had a landscape of temperature. Close to the bright young sun, it was incredibly hot. Any ice or light gases were instantly boiled away, leaving only tiny particles of rock and metal. But farther out, away from the sun's fiery breath, it was much colder. It was a realm of frost and ice, where lighter elements could freeze into solid particles, a cosmic geography of heat and cold. There was an invisible border within this disk, a place called the frost line, or the snow line. Inside this line, it was too hot for water to freeze. Outside this line, it was cold enough for water to exist as ice. This simple fact had enormous consequences. It determined what the planets would be made of, and how large they could grow. It was a dividing line between two different kinds of worlds, the rocky and the icy. In the inner part of the disk, inside the frost line, only the heavy, durable materials survived. These were specks of silicate rock and tiny flakes of iron and nickel. These materials are rare in the universe, so there was not a lot of raw material to build with. This is why the inner planets, Mercury, Venus, Earth, and Mars, are small and rocky. They were built from the scarce leftovers in the sun's hot backyard. In the outer part of the disk, beyond the frost line, the story was very different. Here, it was cold enough for water ice to form in vast quantities. Water is much more abundant than rock, so there was a huge amount of solid material available. This allowed the outer planets, Jupiter, Saturn, Uranus, and Neptune, to grow much, much larger. They started as icy cores and became the giants of our solar system. In the quiet chaos of the disk, a slow and gentle process began. Tiny specks of dust, no bigger than particles of smoke, started to stick together. At first, it was not gravity that pulled them. It was a much gentler force, like static electricity. Think of dust bunnies forming under a bed. The particles bumped and clung to one another, forming fluffy, fragile clumps, a gentle gathering in the swirling darkness. These small, fluffy clumps of dust continued to grow, gathering more and more particles as they tumbled through the disk. As they grew larger, they sometimes melted due to small collisions, and then re-solidified into tiny spheres. These little beads of cosmic glass, called chondrules, were the first truly solid objects in the solar system. They were like cosmic hailstones, growing layer by layer, in a slow, patient process of accumulation. As these clumps and chondrules grew larger, from the size of pebbles to the size of rocks, their own gravity began to take effect. They were no longer just passive objects bumping into each other. They started to actively pull in more material, their gentle gravitational tugs sweeping up the dust in their path. The process of growth began to accelerate. The rich were getting richer, gravitationally speaking. Soon these objects grew to be miles across, small worlds floating in space. These are called planetesimals, the true seeds of planets. The protoplanetary disk was now filled with millions of these small bodies, their orbits weaving and crossing in a complex chaotic dance. They were the first generation of large objects to emerge from the dust, countless small worlds drifting in the dark, the building blocks of the giants to come. The young solar system was a crowded and dangerous place. It was not the orderly system we know today. These millions of planetesimals were on unstable orbits, constantly interacting with one another. Collisions were not just common, they were inevitable. The entire disk was a cosmic demolition derby and a grand construction site, all at the same time, a place of violent and beautiful creation. Some of these collisions were incredibly destructive. A high-speed, head-on crash could shatter a planetesimal completely, turning it back into a cloud of dust and rubble. This set the building process back, forcing the material to start clumping together all over again. It was a process of 2 steps forward, 1 step back, a slow and often frustrating path to building a planet. But other collisions were gentle and creative. If 2 planetesimals met at a slow speed, they would not shatter. They would merge together, forming a single, larger body. This process, called accretion, was the primary way that planets grew. It was a slow, steady accumulation, 1 collision at a time, over millions of years, a patient construction project on a cosmic scale. Through this slow process of collision and merging, our own Earth began to form. It started as a single, fortunate planetesimal, one among millions. But its orbit was stable, a place where it could grow steadily without being destroyed. It began to sweep up the smaller bodies in its path, incorporating their mass and their energy into its own growing form, a dominant object in its local neighborhood. As the proto-Earth grew larger, its gravity became stronger, and it began to pull in material more and more effectively. It became the gravitational bully of its orbit, clearing a wide path through the disk. Each impact added more material, making it bigger, and each impact also added more heat. Over millions of years, it grew from a small rock into a protoplanet, a world in the making, a slow and steady accumulation of cosmic debris. The young Earth was a hellish and alien place, a far cry from the blue marble we know. The constant rain of impacts from planetesimals kept its surface entirely molten. It was a global ocean of magma, a glowing ball of liquid rock. Its surface roiled and churned, with temperatures hot enough to melt any known element. There was no solid ground, no water, no air to breathe, just a fiery, incandescent sphere, glowing a dull red in the blackness of space. This magma ocean was not a shallow pool. Scientists believe it may have been hundreds, or even thousands, of miles deep. The entire outer layer of the planet was liquid. There were no continents, no mountains, no valleys, just a uniform, roiling surface, constantly stirred by convection currents from the hot mantle below. It was a world without features, a blank canvas of fire, waiting for the great event that would change it forever. As the Earth grew and remained in this molten state, a great separation began to occur. The heaviest materials in the mix, like iron and nickel, were pulled by gravity toward the center of the planet. They sank through the lighter liquid rock in a slow, continuous rain of metal. This process, called planetary differentiation, was the world organizing itself from the inside out, creating the structure it still has today. This sinking of heavy metals formed the Earth's dense, metallic core. It was like a great settling, with the heaviest ingredients falling to the bottom of the bowl. This process took millions of years to complete, a slow, internal sorting that defined the planet's future. The formation of this large iron core was essential. It would one day generate the magnetic field that protects us, a hidden shield forged in the planet's fiery youth. While the heavy metals sank to the core, the lighter materials floated toward the surface. These were the silicates, the chemical compounds that make up rock. They formed a thick, deep layer around the iron core, a layer we now call the mantle. This mantle was also molten, a slowly churning ocean of liquid rock, thousands of miles deep, the engine of our planet's future geology. The atmosphere of the young Earth, if it existed at all, was nothing like ours. Any early atmosphere would have been a toxic blend of gases, vented from the molten rock itself, carbon dioxide, nitrogen, water vapor, but no free oxygen. It would have been thick, heavy, and crushing. But the young sun was also very active, and its strong solar wind may have blown this first atmosphere away entirely, leaving the molten Earth bare and exposed to the vacuum of space. This young, growing Earth was spinning incredibly fast, a blur of motion in the void. A day was not 24 hours long. It was perhaps only 5 or 6 hours. This rapid spin was a memory of its formation, the combined energy of all the countless collisions that had built it. Each planetesimal that struck the Earth did not just add mass. It also added momentum, causing the planet to spin faster and faster, like a top being whipped into a frenzy. The source of this incredible spin is a fundamental law of physics, the conservation of angular momentum. As the planetesimals spiraled in and collided with the growing Earth, their orbital energy was converted into rotational energy. Think of water swirling down a drain. It spins faster as it gets closer to the center. The Earth was doing the same, gathering the momentum of all the material it absorbed, a spinning memory of its violent birth. For millions of years, this fiery, fast-spinning Earth was alone in its orbit. As it spun in the darkness, its sky was filled with the cold, distant light of stars and the hazy, ethereal glow of the Milky Way. But there was no moon. The nights were utterly black, lit only by the faint starlight and the deep red glow of the molten ground. It was a solitary world, a lonely dancer in the cosmic ballet. But its solitude was not destined to last. Meanwhile, in the same cosmic neighborhood, another world was taking shape. For a time, it shared Earth's orbit around the Sun, like a shy twin. Astronomers have given this lost world a name from Greek mythology. They call it Theia, after the Titan goddess who was the mother of the moon goddess Selene, a fitting name for a world with a creative and tragic destiny. Theia was not a small object. Computer simulations that best recreate our moon suggest it was a significant world, roughly the size of the planet Mars today. Like the young Earth, it would have had its own iron core and its own rocky mantle. It was a fully formed protoplanet on a long, slow journey that was about to intersect with our own, a traveler whose final destination was a collision of cosmic proportions. The composition of Theia was likely very similar to that of the proto-Earth. It formed in the same region of the solar system, from the same swirling cloud of rock and metal. It was a rocky world, rich in silicates, with a dense metallic core. This similarity is a key part of the story. It is the reason why the moon, Theia's child, is so chemically similar to our own planet. They were made from the same batch of cosmic ingredients, two worlds cut from the same cloth. For millions of years, Theia did not threaten the Earth. It is believed to have been trapped in a special stable point in Earth's orbit. These places, discovered by the mathematician Joseph Louis Lagrange, are pockets where the gravity of the Sun and the Earth balance perfectly. A small object can orbit in these points forever, like a loyal companion following or leading a planet, a place of perfect gravitational peace. There are 5 of these Lagrange points in any two-body system. The most stable ones are 60 degrees ahead of the planet in its orbit and 60 degrees behind. Theia likely formed in one of these 2 spots, a hidden sibling sharing our path around the Sun. Imagine 2 dancers, held together by an invisible thread, circling a central point. For a long time, Theia and Earth moved in such a harmony, unaware of each other like 2 ships passing in a vast, dark ocean. But this perfect cosmic dance could not last forever. The young solar system was still a messy place, and other planets were growing. The immense gravitational pull of the giant Jupiter and the closer pull of a growing Venus began to tug on Theia. These were gentle but persistent nudges. Over thousands and thousands of years, these small disturbances added up, slowly pushing Theia out of its stable and peaceful home. Theia's orbit began to wobble, just a little at first, like a spinning top that starts to lose its perfect balance. The gravitational nudges from other planets made its path unstable, and it began to drift away from the Lagrange point. The wobble grew larger and larger, its orbit becoming more elongated and chaotic. The beautiful, stable dance was over. Theia was now a rogue world, its path no longer predictable, its fate uncertain. As Theia broke free from its stable point, its new chaotic path began to cross the orbit of Earth. The 2 worlds, once peaceful companions, were now set on a collision course. This was not a sudden event. It was a slow, creeping change, happening over millions of years. In the sky of the molten Earth, a new light would have slowly appeared, a light that grew brighter and closer with each passing orbit, a silent warning of the great change to come. We can imagine what it might have looked like from the surface of the fiery, young Earth. A new star would have appeared in the night sky, one that moved against the background of the others. With each passing year, it would have grown brighter and larger. Soon it would have been a noticeable disk, a small second moon. Then it would have grown to rival the size of our Sun. And still it grew larger and brighter, a looming, silent presence, growing to fill the sky, a final, terrible beauty before the impact. The 2 worlds moved toward each other and pulled by the inexorable, invisible hand of gravity. There was no sound in the vacuum of space, no warning bell to signal the impending doom, just the silent, elegant laws of physics, guiding 2 massive bodies to their final, violent meeting. It was a moment of pure cosmic mechanics, a destiny written in the language of mass, and velocity, and gravity, an appointment that could not be missed. The impact, when it finally came, was not a direct head-on crash. That would have likely shattered both worlds completely, creating a new asteroid belt where a planet once was. Instead, Theia struck the Earth at an angle, a glancing blow. It was a cosmic sideswipe of unimaginable scale. This detail, the angle of the impact, is the most important part of the story. It is the secret ingredient that allowed for creation instead of just destruction. Computer models that simulate this event show that the ideal angle was around 45 degrees. This specific angle allowed Theia to transfer a huge amount of its material into orbit, without completely destroying the Earth. A more direct hit would have been too destructive. A more glancing blow would not have thrown enough material into space. It had to be just right, a moment of cosmic precision, hidden within an act of immense violence. The speed of the collision was enormous, many times faster than the fastest rifle bullet. Theia slammed into Earth at more than 25,000 miles per hour, or about 11 kilometers per second, at such incredible speeds. Solid rock does not behave like a solid. It acts like a liquid. The immense pressure and energy of the impact turned both planets, for a moment, into fluid spheres. A splash between two cosmic titans. The energy released in that single moment is almost impossible for the human mind to comprehend. It was equivalent to trillions of the most powerful nuclear bombs ever created, all detonating at the same instant. A flash of light and heat so intense, it would have been visible across the inner solar system. The surface of both worlds was instantly vaporized, turned into a superheated gas, hotter than the surface of the sun itself. This vaporized rock was not just hot, it was a state of matter called plasma. The atoms themselves were torn apart, a glowing, incandescent cloud of what used to be mountains and plains. This cloud expanded outwards at incredible speed, a fiery ghost of two worlds, escaping the bonds of gravity for a short time, the raw material from which a new world would be born. As Theia struck the Earth, its dense iron core did not bounce off or shatter. It plunged deep into our world, like a bullet through water. It tore through the Earth's already molten mantle, sinking under its own immense weight. It traveled downwards, toward the center of the Earth, on a journey to meet our planet's own core, a heavy heart seeking another. Eventually, after a journey through thousands of miles of liquid rock, Theia's core reached the center of the Earth and merged with it. The iron heart of the impacting world became a part of our own. This is why the Earth has a larger and heavier iron core than it should for its size. It is a 2-for-1 deal, the core of two planets combined into one, a secret hidden deep beneath our feet. This larger supercharged core was a hidden gift from the collision. It gave our world a powerful and stable magnetic field, a shield that extends far out into space. This magnetic field would one day protect our atmosphere from the solar wind and shield early life from harmful cosmic radiation. It was a gift of protection, born from an act of destruction, a legacy of Theia that allows us to be here today. While Theia's core plunged into the Earth, the lighter outer layers of both planets met a different fate. The rocky mantles and crusts of Earth and Theia were shattered and vaporized by the incredible heat. The immense energy of the impact blasted this material outwards, throwing a vast plume of incandescent rock and gas high above the planet, a fountain of fire reaching for the stars. The impact was so powerful, it physically deformed the Earth. For a brief moment, our planet was likely stretched into an oblong shape, like an egg. Shockwaves of unimaginable power would have rippled through the planet's molten interior, shaking it to its very core. The entire globe would have rung like a giant bell, a deep, silent vibration that resonated for thousands of years. A world forever changed by a single, violent touch. This incredible event, a world striking a world, happened in complete and utter silence. Because space is a vacuum, there was no air to carry the sound of the impact. It was a silent explosion, a spectacle of light and energy without a roar. The only sound was the deep, internal ringing of the earth itself, a vibration felt but not heard, a silent scream that echoed through molten rock for ages. The impact also did something else to the Earth. It knocked our planet over. Before the impact, the Earth's axis of rotation was likely upright, straight up and down relative to its orbit. The glancing blow from Theia tilted it. The Earth was knocked onto the 23.5-degree angle we still have today. This tilt, a scar from that ancient collision, is what gives us our seasons, a permanent memory of a violent past that gives rhythm to our year. The vast cloud of vaporized debris did not simply fly off into deep space. The Earth, though wounded and glowing, was still massive. Its powerful gravity reached out and captured a huge portion of the ejected material. The debris was pulled back, not to crash into the surface, but to enter into orbit around the scarred and glowing planet. It was a catch, a gravitational net, saving the pieces of the broken worlds. This captured material did not form a random cloud. The physics of its motion, the conservation of angular momentum from the angled impact, caused it to flatten into a ring. For a short time, the Earth was surrounded by a spectacular, glowing ring around its equator. It was a structure of breathtaking beauty, born from unimaginable violence. A temporary crown of fire on a wounded king. This ring was very different from the beautiful, icy rings of Saturn. Saturn's rings are made of countless small particles of water ice, and they are very thin and spread out. The Earth's ring was made of molten rock and superheated gas. It was incredibly dense and incredibly hot. It glowed with its own fierce light, a band of liquid fire in the sky, a short-lived and terrifying spectacle. The ring was also much, much closer to the Earth than our moon is today. It began just a few thousand miles above the planet's surface, a thick churning band of magma droplets and vapor. The particles within it would have orbited the Earth in just a few hours, a swirling cosmic whirlpool of incandescent matter. It was a vision of hell and the cradle of a new heaven, all at once, and so the stage was set for the moon's birth. The raw materials were all there, circling the Earth in a hot, dense ring. The wreckage of two planets was now in orbit, waiting for gravity to do its work one more time. All that was needed was a seed, a starting point, for a new world to begin to grow. The chaos of the impact was over, and the patient work of creation was about to begin. Inside this fiery, chaotic ring, the process of accretion started again. It was the same process that formed the planets, but now on a smaller scale, and happening much, much faster. Tiny droplets of molten rock, like drops of lava rain, began to bump into each other and stick together. They formed small clumps, which then attracted other clumps, a slow gathering in the glowing storm. This process was surprisingly fast. In cosmic terms, the ring was so dense that collisions were constant. A single dominant body began to form very quickly. Some computer simulations suggest that the main body of the moon, a solid sphere, could have formed in as little as a single year. Others suggest it may have taken a century. Either way, it was a lightning-fast creation, a world born in the blink of a cosmic eye. Why did one large moon form instead of many smaller moons? It is a process called runaway accretion. Once a single body in the ring became slightly larger than the others, its gravity gave it an advantage. It began to pull in material more effectively than its smaller neighbors. It grew bigger, which made its gravity stronger, which made it grow even bigger. It was a chain reaction of growth, a gravitational snowball effect that quickly consumed the entire ring. This growing proto-moon acted like a cosmic vacuum cleaner. It swept through the ring, orbit by orbit, gathering up almost all of the available material. Its gravity cleared a path, pulling in the smaller clumps and molten droplets. The fiery ring that had once dominated the Earth's sky began to thin, and then fade away entirely. Its substance was not lost, it was simply collected into a single, new, glowing sphere. The moon was born. This newborn moon was a very different object from the pale, silent orb we see today. It was a ball of molten rock, a global magma ocean, just like the young Earth had been. It glowed with its own intense heat, a dull, angry red, radiating the energy of its violent formation out into space. It was a tiny, fiery star, in orbit around a larger, fiery planet, a double inferno in the dark. And this molten moon was incredibly close to the Earth. Not 250,000 miles away, but perhaps only 15,000 miles. It was more than 15 times closer than it is today. It hung in the sky like a giant, terrifying lantern, a constant looming presence. The bond between the Earth and its new child was intimate and powerful, and it would shape both of their futures. Because it was so close, the moon would have appeared enormous in the Earth's sky. If you could have stood on the surface of the molten Earth and looked up, the moon would have filled a vast portion of the sky. It would have been more than 15 times wider than the full moon we see today. It would have been a dominant, overwhelming feature of the heavens, a constant companion in the fiery sky. How can we know all this? About an event that happened 4.5 billion years ago? The answer is written in the rocks, brought back to Earth by the Apollo astronauts. They returned with hundreds of pounds of moon rocks, treasures that have allowed scientists to read the moon's history. When these rocks are analyzed in a laboratory, they tell a clear and fascinating story, a chemical fingerprint of a violent birth. The moon rocks are chemically very, very similar to the rocks of Earth's own mantle. It is like a DNA test for planets. The specific blend of elements and minerals shows a clear family relationship. It proves that the moon and the Earth are made from the same basic material, that they are kin, born from the same event, a child made from its parent's body. One of the most powerful clues is hidden in the oxygen atoms within the rocks. Oxygen comes in slightly different forms, called isotopes. Every planet in the solar system has a unique isotopic signature, a unique blend of these oxygens. The moon rocks, however, have an oxygen signature that is an exact match for Earth's. This is the smoking gun, proving the moon is made from Earth's material, thoroughly mixed in a great cosmic blender. But there is a key difference that tells the other half of the story. The moon rocks are extremely dry. They contain almost no water or other volatile elements, things that evaporate easily when heated. This makes perfect sense if the moon was born in a fiery, high-energy impact. The intense heat of the collision would have boiled away any water or light gases, leaving behind only the dry, baked rock. A world born of fire would be a world without water. The gravitational pull of this huge close-by moon was immense. It tugged on the Earth with a force that is hard to imagine. This pull had a profound effect on our young, molten planet. It was the beginning of a long, slow conversation between the Earth and the moon, a conversation spoken in the language of gravity, a dance that continues to this day. This powerful gravity pulled on the Earth's molten surface, creating tides of unimaginable scale. These were not tides of water, but tides of liquid rock. The surface of the Earth bulged and stretched, reaching for the moon. These rock tides may have been hundreds of miles high, a constant wave of magma, circling the globe as the planet spun beneath its new companion, a silent, churning sea of stone. This constant pulling and stretching of the Earth's body acted like a powerful brake. It generated immense friction within the planet's molten layers, and this friction began to slow down the Earth's very fast rotation. The frantic 5-hour day began to lengthen, slowly, second by second, century by century. The moon was stealing the Earth's spin, a quiet theft of energy that continues even now. This slowing of the Earth's spin is a beautiful example of the conservation of energy. The rotational energy of the Earth had to go somewhere. It could not simply disappear. It was transferred through the gravitational grip of the tides to the moon. The Earth's loss was the moon's gain. The Earth spun slower, and the moon gained that energy in its orbit, a perfect and elegant exchange. This added energy had a profound effect on the moon. It pushed the moon, causing it to slowly move away from the Earth. Its orbit began to expand, spiraling outwards in a slow, graceful retreat. The closer the moon was, the stronger the tide, and the faster it moved away. The process was fast at first, and has been slowing down ever since. A long, slow goodbye that has lasted for billions of years. This process is called tidal recession, and it is still happening today, right now. We can measure it with lasers bounced off of mirrors left on the moon by the Apollo astronauts. The moon is moving away from us at a rate of about 1.5 inches per year, about the same speed that your fingernails grow. It is a slow, steady, and unstoppable retreat, a cosmic tide carrying our companion farther out to sea. As the moon pulled on the Earth also pulled on the moon. The Earth's immense gravity tugged at the molten moon, creating its own powerful tides on the lunar surface. The liquid rock of the newborn moon bulged towards the Earth, creating a permanent, frozen tide. This tugging from the Earth would have a dramatic effect on how the moon spins, locking it into a unique embrace. This constant gravitational tugging from the Earth acted as a powerful brake on the moon's own rotation. Just like the moon slowed the Earth slowed the moon. The moon used to spin much faster, a blur of motion, but the Earth's gravity grabbed hold of its tidal bulge and over a very long time slowed its rotation down to a near standstill, a cosmic hypnotist calming a spinning top. Eventually, the moon's rotation slowed so much that it became locked in place. Its spin became perfectly synchronized with its orbit around the Earth. A delicate and permanent balance was achieved. This state is called tidal locking. It means the moon now takes exactly as long to spin once on its axis as it does to travel once around the Earth. A perfect, silent waltz. Because of this tidal lock, we on Earth only ever see one side of the moon. The familiar face, with the shapes we call the man in the moon, is always turned toward us. The far side of the moon, sometimes called the dark side, remained a complete mystery to humanity for thousands of years. It was an unseen landscape, a hidden face, until we sent spacecraft to finally look upon it. a secret kept for nearly all of human history. While this gravitational dance was unfolding, the molten moon was beginning to cool, its outer surface, exposed to the cold of space, started to lose heat and solidify. It was like a crust forming on a cooling loaf of bread, or a skin of ice on a freezing pond. This was the birth of the lunar surface, the first solid ground on our new companion, a fragile shell of rock. As the moon's vast magma ocean cooled, a process of differentiation took place, just as it had on Earth. Lighter minerals, particularly a white chalky rock called anorthosite, crystallized and floated to the top. They accumulated into a thick light-colored crust. This became the lunar highlands, the ancient cratered and bright parts of the moon we see today. The moon's original primordial skin, the existence of this anorthosite crust, is the key evidence for the magma ocean theory. This type of rock is very light, and it would only form by floating on top of a vast sea of denser, liquid magma. The rocks themselves tell the story of their own creation, of crystallizing and floating to the top of a molten world, a frozen record of a fiery sea, a story written in stone. At the same time, heavier minerals, like olivine and pyroxene, crystallized and sank through the magma. They settled down toward the center of the moon, forming its mantle, and at the very center, the small amount of iron that the moon possessed sank to form a tiny core. This small core is a crucial piece of evidence. It tells us the moon was made mostly from the light, rocky mantles of Earth and Theia, not from their iron-heavy cores. The moon's surface was once smooth, a fresh crust of white rock. But this pristine state did not last long. The early solar system was still a shooting gallery, full of debris left over from the formation of the planets. This period, from about 4.1 to 3.8 billion years ago, is called the Late Heavy Bombardment, a final, furious storm before the calm. For hundreds of millions of years, the moon and the Earth were pelted by a relentless rain of asteroids and comets. These objects, some as large as mountains, crashed into the moon's new crust. They created the millions of craters that cover its surface today. The moon's face became a permanent record of this ancient violence, a pockmarked testament to a chaotic youth. The Earth was also hit by these objects, probably even more so because of its larger size and gravity. But on Earth, we have an active geology. We have wind and rain and plate tectonics. These forces have eroded and erased almost all of these ancient scars. The moon has no weather and no geology to speak of, so its scars remain perfectly preserved for billions of years. A museum of the early solar system. Some of the impacts during the late heavy bombardment were truly colossal. They were caused by asteroids hundreds of miles across. These impacts were so powerful that they cracked the moon's fragile crust, creating vast, deep basins. The largest of the South Pole Aitken Basin on the far side is over 1,500 miles across and 8 miles deep, one of the largest known impact craters in the entire solar system, a scar of epic proportions. Long after these giant basins formed, the moon's interior was still hot and partially molten. Magma from deep within the moon's mantle began to well up through the deep cracks in the crust. This dark basaltic lava, which is similar to the lava from volcanoes in Hawaii, flowed out and filled the low-lying basins. It spread out in vast flat sheets, like water filling a bowl, a slow flood of liquid rock. When this dark lava cooled and solidified, it formed huge, smooth, dark plains. These are the dark patches we see on the face of the moon. Early astronomers, looking through primitive telescopes, thought these dark patches were seas. They gave them Latin names like Mare Tranquillitatis, the Sea of Tranquility. They are not seas of water, but frozen seas of ancient lava, a dark ink blot on a pale page. An interesting mystery is why most of these dark maria are on the near side of the moon, the side facing us. The far side is almost entirely bright, cratered highlands. The reason is likely that the moon's crust is thinner on the near side. The Earth's powerful gravitational pull may have distorted the young moon, leaving a thinner crust on the side facing us, making it easier for magma to break through to the surface. The moon has no atmosphere to speak of. Its gravity is simply too weak to hold onto a blanket of gas. This means there is no wind, no weather, and no protection from the harshness of space. The sky on the moon is always black, even during the day, and the silence is absolute, a profound, unbroken quiet that has lasted for billions of years, a world of perfect stillness. This lack of atmosphere and weather is why the moon is such a perfect historical record. Every crater, every landslide, every footprint left by the Apollo astronauts remains perfectly preserved. It is a world without erosion, without change. A footprint there could last for 1,000,000 years, a silent testament, frozen in time, in the grey dust, a story that will not be erased. The moon's gravity, though gentle, has a profound and stabilizing effect on our planet. The Earth's axis, tilted by the Great Impact, would naturally wobble over long periods of time. This wobble, without the moon, could be chaotic and large. The moon's steady gravitational tug acts like a balancing pole for a tightrope walker, keeping the Earth's tilt stable within a narrow range, a gentle hand on a spinning top. This stability is incredibly important for life on Earth. A stable axial tilt means a stable climate. The seasons remain predictable, and the polar ice caps and equatorial regions stay where they are, without the moon. The Earth's axis could swing wildly, causing catastrophic changes in climate over thousands of years, making it much harder for complex life to evolve and thrive. The moon is our anchor, our climate regulator. The most obvious effect of the moon on Earth is the ocean tides. The moon's gravity pulls on the water, creating a bulge on the side of the Earth facing the moon, and another on the opposite side. As the Earth rotates, these bulges sweep across the oceans, creating the familiar rhythm of high and low tide. It is a constant breath, a slow, deep sigh of the ocean, orchestrated by our distant companion. These tides may have played a crucial role in the very origin of life. The constant cycle of wetting and drying in tidal pools along ancient coastlines could have created a perfect chemical laboratory. This process could have concentrated simple organic molecules, encouraging them to link up and form the first complex building blocks of life. The rhythm of the tides may be the rhythm that kick-started biology on our planet, the pulse of creation. The moon has also been a constant in our sky, a clock, a calendar, and a source of light and wonder. Its predictable phases, from new moon to full moon and back again, provided early humanity with a way to measure time, the first month. Its gentle light has guided nocturnal animals and lost travelers for millions of years. It is a quiet, humble, and essential part of our world's story. Today, the moon is a quiet and peaceful place. The age of violent impacts is long over. The volcanic fires have gone out. It is a geologically dead world, a sphere of rock and dust, sleeping in the cold of space. But its silence is deceptive. It is a silence full of history, a quiet that tells the loudest story imaginable, the story of its own birth and ours. And its journey continues. Its slow, steady retreat from the earth carries on inch by inch, year by year. Billions of years from now, it will be much farther away and appear much smaller in our sky. Eventually, the Earth's rotation will slow to match the Moon's orbit, and the two worlds will be tidally locked to each other, always showing the same face to one another. A final, silent embrace at the end of a long dance. When you look up at the Moon, you are looking at a piece of the ancient Earth. You are seeing a part of our own world that was thrown away in a moment of violence and then returned to us as a beautiful, silver companion in the darkness. It is a piece of home, floating far away, a constant reminder that we are part of a much larger and more ancient story, a story written in starlight and stone. The dust of that ancient collision has long since settled. The fire has cooled. The noise has faded into an immense cosmic silence. All that is left is the quiet grace of the Moon's orbit, and the steady, silent gaze it keeps upon the Earth. It is a symbol of tranquility that was born in a storm of fire and rock, a peaceful face that hides a violent past, a lullaby from the cosmos itself. Our journey through this ancient story is now complete. The chaos has become calm. The fire has turned to cold, silent rock. The violence of birth has faded into the quiet rhythm of the orbit. All that remains is the gentle light and the peaceful presence of our Moon, our constant silent companion. If you enjoyed this quiet journey, I am glad you found your way here. It helps others find this peaceful corner too, one sleepy soul at a time. And now, just breathe. Let your eyes close and let the quiet Moon lull your thoughts to sleep. Good night.